students. Today we are adding and subtracting polynomials. We are on chapter 11. I am Miss April. So let's get going. The key to success is understanding what like terms, unlike terms are, and if you don't know, what is a term? Well, okay, let's say we have something that looks like all right, so how many terms do we have in this expression? Well, we can divide a term in front of either the subtraction or addition in a polynomial. Does not include division or multiplication of terms, of coefficients to the variables. What it does include is whatever is being separated through addition or subtraction. So there's 1, 2, 3, 4 terms here. Okay, so if we know that there are 4 terms, we can ask ourselves, well, now that I know what terms are here, are any of them like terms? Well, start at the beginning. Are there any x3s? No x to the thirds. I have an x to the second. Oh, look, I have another x to the second. And they happen to be, well, a negative 7x squared and a positive 7x squared. They kind of cancel each other out. And then I have this term. And I can't combine the other two. So what I'm left with when simplifying is this. Okay, so understanding that we can simplify only like terms. What's left are unlike terms. In exercise 11.1, if we look at number 1, we see that 6x plus 2x is our given expression. And we can add those two together because they are raised to the same power, 1. So 6 plus 2 is 8, and we have 8x. Simple. Let's go to 12. We are given a negative 10x to the third minus 3x to the third plus 14x to the third. And it just so happens that they are all raised to the same value, which means that we can subtract or add as indicated. So we are going to just start from left to right, and we see a negative 10 minus 3. Negative 10 minus 3 puts us more negative. So we have a negative 13x to the third plus a 14x to the third. So now we have a negative 3 plus 14. And I'm just showing you every step, writing every step down here for you. So negative 13 plus 14 leaves us with 1. And we usually don't even write the 1, right? So we are left with just simply x to the third. Let's take a look at one more here. How about number 15? We have a negative 1.5 z to the second plus 4.3 z to the second. Now I cross my z's because otherwise they look like 2's. And, lost my place. Okay, there we go. 2.1 z to the second. They're all the same raised to the same term, the same exponential value. And so we can just add left to right. We have a negative 1.5, and we're adding 4.3. And what we're thinking here is that basically we have 4.3, and we could subtract 1.5. When we do that, we wind up with 2.8. Now we're taking that 2.8, z to the second, and we're adding the last value, 2.1. So that leaves us with 3.9 z to the second as our final answer. It is simplified. Let's move on to 11.2. So let's talk about adding and subtracting the polynomials themselves. So a polynomial is, multiple terms, and we have binomials, trinomials, and then we just go to polynomials. So let's look at 11.2 and talk about some of these. In number 1, we have the parentheses that separate our different polynomials that we're adding or subtracting together. And of course the adding is a little easier because we don't have to worry about changing the signs in the second polynomial. So simply when we look at this, if we want to, but only when we're adding, okay? If we want to, we could remove these parentheses, only for adding. We'll remove the parentheses, and we'll look for some like terms. I did not mean to do that. I have an 12x to the third power. Do I have any other x to the third power? There's one. I have a negative 5x to the second power. Do I have anything else to the second power? Oh, I do right there. And then I have just the x value, none other. And that one I'm going to put the 3 lines under. And now I have 2, 3, 4, 1, 2, 3, 4. Okay, now these have to be written when simplified and like terms are combined from the greatest exponential value to the least. So we will look at the 12x to the third and the 3x to the third and add those together. So we have 15x to the third. Next we will do the x to the second power values. The coefficient here is negative 5. And what are we doing over here? We have a 7, negative 7x. So we have a negative 5 plus a negative 7, or negative 5 minus 7, however you want to look at it. It doesn't matter. It's the same result. We're going more negative and a negative, well, you can just add the 5 and the 7 together. Okay, now coefficient for x with no exponent is 10, and we don't have anything else with the coefficient, with the x value, not raised to any power, so we'll just write the 10x. And then we have our constant values here. We have a negative 60 minus the 1, leaves us with a negative 61. That is the addition of these two polynomials. Now let's look at subtracting. Subtracting is slightly more challenging. That was number 1. Let's find one that's subtracting. Okay, let's do number 4 together. We have a 10x squared minus a 5x plus 3 minus 6x, and I am going to keep that in the parentheses for now. 5x minus the 13. Okay, now this is really important. What this does, this subtraction between the polynomials, you kind of have to think of it as a negative 1, a -1 here that you have to distribute to every single term. And that flips the sign. Flips the sign of everything there. So I'm going to go through and, well, I think first I will go ahead and write the first trinomial here, plus 3. Okay. Now the negative has to be applied to the 6x, so -6x. I need to flip the sign of the 5x, so -5x, and that would be a positive 13. So everything in this second polynomial, when subtracting, the sign is flipped. From the beginning, you can see this becomes a -6, becomes a -5, and a positive 13. All right, so let's look at combining like terms. There is nothing like this one. I do have 2 like this. Oh, 3. And then we have a constant. So we'll start with the 10x squared. Next, we have the x. So we have a -5 and a -5, that's a -10. We're subtracting another 6. That is a -16x. We have a positive 3 and a positive 13. We add those together and we get a positive 16. And there you have it. So just remember that when you're subtracting, you need to basically flip the sign of everything in there in the following polynomial. The trickier ones that are at the bottom there. How about number 12? We have subtract a certain value, a particular trinomial that they're giving you, from 0. Okay. And I'm still going to write the parentheses there, because that is key to having the right sign. Now, I will go through and I need to flip the sign. For each one of those, okay? And I can put my 0 up here. But there's nothing there. So my final answer is just this. All right, so that's chapter 11, short and sweet. I will see you for chapter 12.